Hello, in this DD Lab video we're going to show you how we can use some of the unique features of Danfoss digital displacement technology to improve the performance of mobile equipment combining propel and work function. In the truck behind me, we demonstrated the possibility to save a lot of fuel, improve performance and drivability, but also downsize the engine. The electronically controllable system allows us to emulate various drive feelings such as hydrostatic transmission or torque converter. And this gives a unique opportunity to manufacturers to customize the system for different markets. My colleague Paul will now explain how it works in a bit more detail.
So it's centered around our multi-service DDP here. The multi-service nature of the DDP comes from each of its valves being individually controllable. And we've got it split into 3 services here. And this is like having 3 small pumps all in the same body, and they can all work at different pressures and flows. So the first service is connected to our propel block here, which drives a Danfoss H1B conventional bent axis motor, and that drives the wheels. The second service is connected to the standard work function manifold of the forklift. And finally, the third service does what we call dynamic ganging, where the displacement from this service can be connected to either of the other 2 depending on the needs of the driver in real time. This is managed by the DDP controller here, and also our Danfoss +1 safety controller, which does the high-level system control for the system. We can demonstrate the dynamic ganging system on the forklift by doing a full speed lift like this, where all of the flow is going to work function. And then if we repeat the same thing while also driving forwards, you can see that the lifting speed is reduced because the dynamic ganging service has been applied to propel instead.
We carried out the fuel consumption and performance test of this forklift before its upgrade to digital displacement. And compared to that baseline, we have measured up to 41% fuel consumption reduction on a VDI 60 duty cycle. This reduction is enabled by high transmission efficiency and improvement in engine power management.
We also compared the performance of the DDP truck to the baseline truck, and in every test that we carried out, the DDP truck was able to match or even exceed the performance of the baseline truck. But one of the particularly interesting results that we found was the acceleration, and this is shown in the graphs here. You can see that the DDP truck is able to accelerate significantly more quickly than the baseline truck. Because the DDP truck uses the engine's available power more efficiently, it would be possible to match the performance of the baseline truck with a smaller engine and the DDP system. To test this, we applied a 36 kilowatt power limit to the DDP truck's engine and repeated the acceleration tests, and you can see those graphs here. And certainly in the unloaded case, the performance was comparable to the baseline truck. One of the other unique advantages of the DD propel system is that the driving behavior of the vehicle can be tuned entirely in software, so that the behavior can be easily adjusted to customer requirements. For example, in this forklift, we've created both a torque converter and a hydrostatic drive feeling with different softwares. At the moment, the truck is in hydrostatic mode, which means that if I put it into forward, release the handbrake, nothing will happen. But as soon as I press the accelerator, it'll start to drive, and then as soon as I release the accelerator again, it'll come to a controlled stop with hydrostatic braking. So now I'm going to put the truck into torque converter mode and release the handbrake, put it into forward, and it'll start creeping, and I can accelerate, release the accelerator, and it'll coast, and then I have to stop with the service brakes. So completely different drive behavior achieved purely with changing this single switch here.
This system architecture shows how flexible and versatile digital displacement can be. it can really help reduce the total cost of ownership of such equipment by reducing fuel consumption and improving performance of the system. By combining the efficiency of digital displacement with the reliability and ruggedness of hydraulic motors, Danfoss is really providing a pathway to reducing CO2 emission in the mobile market. Indeed, the same technology can be used in ICE internal combustion engines, such as this forklift, but could also be used to electrify mobile equipment. If you're interested to try this technology, we invite you to come and visit us in our facility.